All right, guys, these are our pedigree notes. A pedigree looks like a family tree, but it also shows genetic information. And there are different symbols that represent different things. We're quickly going to work through some of them. The first thing to know is that males are shown with squares and females are shown as circles. So it looks like a family tree working your way down full of circles and squares. The way we organize it is we mark each generation with a Roman numeral. So if you look over here, this first generation is Roman numeral 1. Their children are going to be Roman numeral 2. You have these horizontal lines to show when a male-female couple has reproduced. That line down shows their children. Their children are listed left to right, oldest to youngest. So in this case, if you are looking at a particular trait, anybody with that trait is going to be shaded in. So this square tells us male. The fact that he's shaded in means that he has whatever trait this family tree is tracking. Looking at the line, so this is the couple that is reproduced, their children. This female daughter, circle, and the oldest child, because it's furthest on the left, also has the trait. The two younger sons or younger brothers do not have the trait because they're not shaded. So again, we know he has it. We know she has it. They don't. So let's look at this family tree together, or this pedigree together. We have the first male-female combination, and you can see this female would have the trait. So think about it. What generation would we call this? We would call this Roman numeral 1. They had 1, 2, 3, scratch that one. 1, 2, 3 kids listed from left to right. The oldest son and the youngest son each reproduced, and that is our generation 3. So that would be Roman numeral 3. And then this match had a generation 4. Filling in what we know, we number them left to right going down through the generations. So we have generation 1 with a Roman numeral, person 1, person 2. Then we go down to generation 2 and we number them across. Generation 3, generation 4. You see a total of 6 people in the family have the trait. And the individuals that have it are second generation. It's only asking about males. So second generation, number 5, third generation, person 2 and 3, and then fourth generation, person 1. If I sound like I'm rushing, it's because I am. I only have 5 minutes to do this thing for free. All right, so looking at genotypes, you fill in what you know. So typically what you do is you start at the bottom and you work your way up. So in this case, if somebody's shaded in, based on the information on the right, we know that they are homozygous recessive. So we can go ahead and fill in those because we know them. If somebody is not shaded in, they have to have at least one big N because they are expressing the dominant trait. So at that point, you can start working your way up to see what you might know. Starting with this guy, if he is little n, he had to get those little n's from somewhere. So it must mean that each of his parents have a little n. Same thing applies here. If he got a little n, that means this parent has to have a little n to give him. You work your way up and you see it. Working your way up here, this combination produced a little n. So what must this spot be? He has to have that little n if that's what the youngest son received. With that information in mind, then you can fill in the rest of this chart. Go ahead and figure out what this person could be. I'll put this video on a separate link. The answer to that last one is that you can't tell for sure with that kid.